Hi, I'm Bob Craycraft with the University of New Hampshire Center for Freshwater Biology. I'm the lab manager here, and we're in the process of talking about a procedure for measuring dissolved color. This is the second part of a two-part film clip series. And what we have to my right are some standard solutions, some color standard solutions, and then further off to the right is a spectrophotometer, an instrument that's used to measure differences in substances by passing a beam of light through a little chamber. Let me just open the unit up. So we have a little cell that the sample goes into. A beam of light is emitted from a light source in the spectrophotometer. Over here, there's a receptor on the other side, and you're measuring absorption of the solution, the material in the solution, in this case, the color compounds. So we're effectively measuring things like tannins and lignins, things that cause wetlands to become fairly colored, and lakes as well in some cases. So I had a purified water in the sample, so this chamber is all rinsed out. And what we're going to do is measure the absorption of a couple of solutions, a standard that's fairly high in colored solution and one that's fairly low. So the yellower it is, the more that colored compound in there, the lighter it is, the less. The thing with the spectrophotometer is it can pick up subtle variations in the amount of color of these solutions. Here it's very obvious that there's a difference between the two, but in many cases it's a much more subtle difference between successive solutions, and the spectrophotometer is instrumental in picking up those differences. So I'm filling this chamber and I'm spilling a little bit, which ideally I wouldn't want to do, but should that happen, I do have special pieces of lint-free paper, Kim wipes they're called, kind of like paper for wiping off eyeglasses, and I'm getting off any spilt solution and also doing that in a circular motion to wipe the face of this chamber clean, because the light beam is going to pass through two faces of this chamber. I'm going to place the cylinder into the spectrophotometer, and on a printout to the left here, I'll hit measure, and it's going to give you absorption values at different wavelengths. The bottom line with this is the higher the absorption value, the more colored solution there is in the water. And what I really want to do is run two samples, this sample and then the next sample. So for instance, at 440 nanometers, we're getting an absorption value of 0.112 with this fairly colored solution. Now, if I go ahead, rinse this chamber out between successive samples, and I'm using purified water here, so rinse it, and then take our solution from our second sample, so our fairly low colored solution, rinse out a little bit more with a little bit of that solution, then fill this chamber up with this standard solution. And we could do the same thing with lake water or stream water samples. And based on those absorption values, that'll dictate what the color concentration is in these samples. Now again, I've spilt a little bit of solution. I want to make sure these faces are clean, so I'm wiping these with these Kim wipes, these lint-free papers. Both sides. I'm going to place the chamber, known as a cuvette, back into the spectrophotometer. I'm going to tell it to measure the sample. Oops. Tell it to measure the sample. And the first time for that first absorption value, we had 0.112. Now we're getting 0.007. So it really does show you that there's a tremendous difference in the amount of this solution between the two samples, the amount of these colored compounds. And what we tend to do, I'm just going to put a printout here, a graphic, but we plot that absorption value versus the color concentration of our standard solutions. It gives a nice linear relationship, and we can generate a mathematical formula then that we can apply to the unknown samples, and based on those absorption values, that'll tell us how much color concentration there is in those samples. So effectively, a wetland that's very tea-colored would be have a lot higher value than a lake that doesn't have any wetland drainage at all. And I also have our standard data sheet. In this case, I haven't actually filled it out, but if we were going through the full analytical process, we'd have all the standards listed on here, all the samples, the unknowns listed on here, and then all the corresponding data, including those absorption values, which would be used to derive what the concentrations were.